In the AWS Developers Podcast this week, we're talking about SurrealDB. One of my colleagues this morning said, I love the name. Just the name is great. Thank you for listening to the AWS Developers Podcast. We're recording this episode from the summit in London. That's why you might hear a bit of background noise behind us. We are live, or we are recording live from the expo floor here in the Excel Center in London. And today I have a guest to talk about SurrealDB, an open source database. Toby, thank you for being here in the podcast and being here at the summit. You're the CEO, the co-founder of SurrealDB. What is SurrealDB?
Hey, look, first of all, thanks for having me. It's brilliant to be on this podcast. So SurrealDB is a multi-model database. What that means is we can support time series data, document data, tabular data, so what you might find in a relational database, and then graph-like data. I think one of the most interesting aspects of SurrealDB is that we separate the storage from the compute. So you can run SurrealDB in Python, embedded, let's say, or in Rust, or you can scale out to a single node server or multiple node servers in a distributed cluster. So you can scale up.
Looks like you want to do everything at once. You want to address the embedded world, server world, cloud, but also different types of models. So why need for such a multimodal database? What's wrong with a traditional relational database or key value or document DB?
Yeah, I think what you find in a lot of deployments nowadays are people building with a time series database, a relational database, a graph database for some graph analytics. They've often got an analytical database as well. And SurrealDB simplifies that. So that's not necessarily the way that people use SurrealDB initially. But they might start by saying, look, we want to combine document and graph in order to do better analytics with vector search. But then you can then expand on that and say, actually, you know what? I can now bring time series data and normal tabular data into that data store and analyze that in an alternative way alongside that graph and document data. And then I can get better insights into that data. And most people are doing that, but they're having to spin up and manage 5, 6 different databases. They're having to build a layer in front. They're having to store data in the different ways that the different databases expect. And then they're having to query that data from those different databases. Some of those, you might have to pull down the data into your application layer and manage the query there. So that people are doing it. People need to do it, but it's not necessarily done the right way.
Or sometimes they use the wrong database for the wrong data model.
There's that as well.
Trying to put key value inside a relational database or
exactly.
Or the other way around. I saw some horror stories on DynamoDB, for example, about that. Maybe it's a naive question, but the reason why we have different modality, if I can say like that, for database is to create the best of breed, more performant or adapt database engine for a specific data format like document or key value. How do you manage to do all of them in one engine and to be performant at the same time?
Yeah, it's an interesting question. So document, how we store data in SurrealDB is effectively as a document. So we don't store things in a columnar way. We store things in a document way, a row level way, effectively. I think when you're dealing with graph data, that actually maps very nicely to key value data. So be able to go directly to a record. And in SurrealDB, we have an SQL query language. It's very similar to ANSI SQL, but it has some slight differences. And one of those differences is without using an index, you can go directly to a particular row in a table or particular document in a table. And then you can use that same query type or query functionality to jump between records in different tables, and to perform effectively bidirectional querying. So that's how the graph and the document come together. In a similar way, because we have the concept of tables, so we are more similar to a MongoDB or a Postgres than we are to something like Neo4j. You can actually select data from specific tables as opposed to selecting data based on properties or metadata or relationships. So it still enables you to work with graph and with key value in a very, very performant way. But then it enables you to search in the same way that you might do in Postgres or in MySQL or in MongoDB through tables or through collections with indexes and with filters. So by combining those two together, this is, as I said before, this is what people are doing out there, but they're having to use multiple different databases to do it.
with all the overheads of managing, installing, securing multiple database engines, having to learn different query languages as well. So it means as a developer, I can start with SurrealDB by defining a schema like I do on traditional relational database with tables and columns, or go totally key value without schema and use it more like a DynamoDB, for example.
Yeah, so the key... going back to the beginning, you don't have to use a schema. So you could do completely schemaless, or you could add schema to certain fields. So you have that document aspect where you can have nested objects, nested arrays, kind of arbitrary depth JSON data effectively. But then you could also add schema to that JSON data. We support key value in that you can go directly to a record, but the value of that record is always a unstructured or structured object, as it were. So it could just be a single document with a field, which is just byte data, if you wanted to do that. But also it could just be a JSON object that you store as the value of that object. So it's key value, but it still enables you to store structured data in that value for that key.
Looks like magical to me.
That's why we're called Surreal.
Hence the name. Okay, no, I get it. As a developer, how can I get started? There is a package to download, something to install. If I want to start something small on my development machine.
Yeah, absolutely. So a number of ways. If you're a Rust developer, you can get started embedded within Rust.
Inside the same process.
Exactly, inside the same process to start building. We're also working on our own Rust-based key value store, which means it's completely Rust-based and it doesn't have to use any libraries to build that. But most people are starting by starting up a server and then connecting to that with one of our SDKs, whether that's Rust or Python or Golang or JavaScript. And you can start simple. So I think the most interesting thing about SurrealDB is it doesn't matter how you develop. You can start developing as an embedded in-process library. You can start developing as a single node server, or you can then upgrade and expand and use exactly the same functionality or deployment functionality inside CI/CD. And then when you want to scale into production, you can then run that on a 50-node cluster. So there's no difference to your application in terms of how you build or query things. Okay, sure, you're going to have to think about things maybe in a slightly different way if you're dealing with petabytes of data rather than megabytes. But there's no difference to how you would write your queries. You can just connect to a different endpoint in the different deployment options as you go forward.
So it's the same SDK that I include as a developer, and
exactly.
The SDK is configured to talk either to the embedded engine or the small server running on my laptop or a multi-node cluster running in the cloud.
Exactly. So if you could imagine with another database, you might have a connection string. In SurrealDB, that connection string could be a remote cluster, it could be a single node server, or it could be memory or a local file pointer, and that will store it locally and run an in-memory or local database.
Is there also a CLI to manage my schema or my data like we can find in other databases?
Yeah, so we don't yet have a CLI for managing schema, but you manage schema through the SQL query language. So you use define statements and remove statements, and you can build up and visualize your schema in there. We've also got a user interface called Surrealist, and this enables you to more visually see and edit and work with your schema and your data in different ways, whether that's in a tabular-like way, a document-like way, or even a graph-like way.
So it's a web app that I have to install on top of it, or it's
a web app available at surrealist.app, but it's also available as a desktop application, as a Docker container, and we're looking at also bundling it with the database itself on a port. So
that's a super convenient way for a developer to create a first schema and to start to interact with the DB engine without having to write code first.
Exactly. And you know what? Because of the way that you can deploy SurrealDB being very kind of flexible, all of our documentation actually runs SurrealDB in the browser. So it compiles into WebAssembly. It's about 3 megabytes compressed, or just under 3 megabytes compressed. And our examples, all of our tutorials, our university course, they all have SurrealDB running in the browser, and you can actually run and store megabytes or gigabytes, if you allow that in your browser, of data right there on your desktop locally.
So as a web developer, I can also include SurrealDB engine and storage inside my web application?
You can do that as well, yeah. So you could store data in memory, or you could store data on top of IndexedDB. So we use IndexedDB as a rather kind of basic key value store, and we store data in there.
that opens the field to another set of questions. How does it work behind the scene? You said there is a separate layer between the compute and the storage. So what are the key components inside the engine? What programming language do you use to develop that? And what does it mean to install SurrealDB on large cluster? You have multiple installation. Okay, maybe let's start with the simple case where we talk about an embedded system.
Yeah, so SurrealDB is completely built in Rust, 100% built in Rust, which is a brilliant language. We made the best choice we actually built it originally in Golang, while we were building the prototype and using that internally, and then we decided to rewrite it in Rust, which is one of the best decisions we could have made.
Typically, developers says Rust. There is a small learning curve for that, but the benefits is the strong typing and all the checks the compiler is doing for you, not only on type but also on the multi-threading system. That's the type of benefits you get from Rust, and the performance of a native binary package.
Yeah, I think. Look, something like Golang was brilliant, right? As I said, 100,000 of the lines of this database was written in Golang originally, and it enables you to get building in half a day, maybe even less. Rust definitely has that learning curve. You have to understand the borrow checker. You have to understand many aspects of what you're building, but also the language itself. What I would say is when you get to a point where you need to have more control over what your application is doing or how it's doing it, that's where Rust really shines. In Golang, you may have 3 or 4 different ways of doing something, and it's usually via channels or Go routines. In Rust, you have 100 different ways of doing that. They all have different complexities in terms of the coding, different benefits, different negativities, but you have the choice as a developer, and you can decide the complexity of the end results in terms of how it's built.
When did you start developing SurrealDB?
So SurrealDB was started to be built in Golang in 2015. That was that's when
10 years ago.
Yeah, so 10 years ago we had the initial idea for this is what we want to build. How do we go about doing this? We're looking to build something that effectively a lot of people say it's too good to be true. Right? That's the very first thing you say.
That's my first focus. Well,
so how do you actually store document data, graph data, key value data, make it scale, but also do that in a performant way? And that's definitely the first objection we get. But when you actually show what people can do with the query language and the performance that you have with that, I think people are blown away. But yeah, so 2015, we started building that, started working on the underlying key value store. And I'll come back to your question in a minute about how it actually works. But that key value store was a key part of that process in actually building the layer above it. Then we worked on the query language above that so that it felt very natural to someone coming from MySQL or Postgres, so effectively similar to ANSI SQL, but slight differences, but enables you to also work with document data, so similar to if you're coming from something like Couchbase or MongoDB. And then we started using that 3 years later in applications and platforms that we were building. This is me and my co-founder, my brother. And then a few years later from there, we realized that what we were building in terms of the database was far more powerful than the applications we were building on top. So that was 2021, and we spent 1 year learning and rewriting it in Rust, and then we open sourced it in 2022.
Wow, 1 year to rewrite the entire database engine and storage in Rust?
I think the hardest aspect was we knew what we wanted from the database engine. And if you're still working that out and you have to go through redesigns of the source code to do that, then that's a challenge. Because we knew what we wanted to build and how we wanted it to work, that definitely made it easier. Don't get me wrong, there is still, as you said before, a very significant learning curve when you come from a language like Golang into Rust. But as I say, totally worth it.
So let's go back to the questions. What are the main components? There is the front end, the query front end, the processor, and then
yeah. So effectively, we've got our own parser. It used to be a parser combinator that we used to write that parser. We've now completely built that, rebuilt that, should I say, with a recursive descent parser. So it recursively descends by hand through the language. Once it's parsed that into an AST, we then push that through something called an executor. The executor understands something I should probably explain is everything in SurrealDB is based around transactions. So it's fully ACID compliant if you're not running in memory, that is. And therefore, you have transactions for the different queries, or you can use a begin and a commit or a cancel statement as well. So the executor handles the transaction logic and then pushes those groups of transactions to something called an iterator. that iterator then understands how it should query to the underlying key value store. And that's really the main point. So every single implementation that we support, whether that's an in-memory engine, a IndexedDB-backed WebAssembly engine, a RocksDB or SurrealKV single node engine, or even if it's a distributed storage cluster, it all has the same interface. And that is effectively the ability to, in a transaction-like way, so with the support of transactions, able to get a key, set a key, get a range of keys, get a range of keys in reverse, and delete a key. So effectively, a few more methods in addition to that, but effectively those are the methods. And we need to support those just with binary data. So the key is a binary VEC-U8, and the value is the same, the binary VEC-U8. And from that, everything else on top of that is built and works in the way that you would expect a database to work.
Did you write your own storage engine as well, or you just interface with existing like IndexedDB you mentioned for web app?
Yeah, so IndexedDB, we literally just use the two column table with key, which is a uint array, and a value, which is uint array. And then again, we the database handles the storage of that. So we don't use any of the other logic that IndexedDB gives you. We use RocksDB. Initially, that was the first thing we supported when we moved to Rust. We actually had our own key value storage engine in Golang, but porting that over to Rust was a little bit more complex. We've been working for the last year and a half on something called SurrealKV, which is a fully 100% Rust-based key value store, ACID compliant. You can use this. It's open source. You can use this in your applications. Similar, if you're in the Rust ecosystem, to something like Sled. But again, 100% Rust-based and based around radix tries, and we're also doing research and investigations around B+ tries and B+ trees as well. And that is our own key value storage engine. So RocksDB and SurrealKV are two options that you can run when you're running locally or on a single node.
Yeah, and that was my next question. You also mentioned multi-nodes type of cluster or distributed storage.
Yeah.
Did you reinvent a distributed storage layer?
So we haven't. So from a distributed storage point of view, you can run on something called FoundationDB, which is open source and managed by Apple now, or TyKV, which is built by a company called PingCap. We're also working on our own distributed version of SurrealKV. So effectively, SurrealKV is the first building block, single node, and that will then become a part of our distributed storage engine in the future.
I have a naive question again. It's the AWS Developers Podcast. At AWS, we have a quite well-known distributed storage. It's called S3. Does it make any sense to have S3 as a storage layer?
I think the problem with something like S3 is you could do that, but it'd be very hard to support transactions. So what you find with something like FoundationDB or TyKV and what we're building with SurrealKV in a distributed storage is the replication protocol for supporting those transactions. So effectively, the nodes in the clusters saying, yes, there's a quorum for this transaction, for this data which is being set, and now this you can consider this transaction set across the cluster. Many people use Raft. We're also building on something called Tapir, which came out of Microsoft Research, but they're very similar. And when you build it on top of S3, often what you'll find, and there are implementations out there built by, I think, correct me if the name is wrong, but Redset, which was just bought by OpenAI actually recently. Effectively, they have a layer which sits in front of S3. It stores data to S3, but it's always single writer, multiple readers, and it uses Kafka for that distributed transaction queue. But that means that you can't actually scale up the writes. With Tapir or with Raft, you can then scale out those writes and reads, so you can scale up the cluster horizontally and increase the writes as you need.
And again, I'm biased towards cloud deployment here. So you said it's one simple installation if I want to embed SurrealDB into my app. But imagine that I want to deploy in the cloud. How does it work? Do I need to install the front end, the storage layer separately? Maybe a network load balancer? What's the typical architecture to deploy on multiple nodes?
It's a good question. You can do it in many different ways, obviously.
Typical.
SurrealDB runs as a binary. It's a single binary that you can run. But you can also run it in Kubernetes in a Docker container if you want to. So actually, we've launched our cloud in December last year, running on AWS, and we're using application load balancers. We're using Kubernetes. I think we may be using ECS under the hood as well. And so as a developer, you can choose if you want to run in a distributed manner. You can choose your storage engine. You can scale that out through Kubernetes as well. And then and one of the benefits of SurrealDB is you can scale out, but you can also scale down when you don't need to. So lots of different ways, but effectively, it's designed to be easy to scale and easy to manage. You don't have to think about, do I need to run a distributed storage system in terms of a distributed file system? Do I need to run Zookeeper? Do I need to run something like that? You don't need to think about that. It's effectively just, if you want to run distributed, 2 Docker container types. One is for the storage engine, and one is for the compute engine, the SurrealDB compute engine. As easy as that. I always wanted to build a database that was kind of native for the cloud, right? Native in terms of the applications being built, but also native in terms of the way that people want to deploy it and manage it.
How much did you know about database technology and architecture when you started that project 10 years ago? It's a very specialized field of computer science.
It's a good question. Very little, actually. And I think if I'd known more about it, I probably wouldn't have started on this journey. I did my master's in computer science at Oxford in key value stores for distributed graph databases, and that was my initial interest into this space. Before that, it had been purely about building on all these different databases. So I had experience of RethinkDB, MongoDB, DynamoDB, MySQL, which was the flavor back then, obviously Postgres nowadays, InfluxDB, Neo4j, ArangoDB, OrangeDB.
Yeah, but using this database as a developer or understanding the internals of a database, it's a really different set of skills.
Definitely different to building your own. Yeah, absolutely. And I think that's one of the reasons why I find myself here today, which is I didn't have the knowledge of what actually it would take to build a database. And therefore, I arrogantly thought it'd be something I could do. I think that's definitely the best part of it. Yeah.
So now you're a database expert as well. What are the challenge or the lesson learned when you build SurrealDB? We talk about a few already, learning Rust, becoming a database engine expert. But yeah, what were your main challenges?
I think the hardest aspect was actually working out how to write the query language in a way that it can support these different models of data. I think the query language looks very similar to ANSI SQL. It's got select statements, it's got insert statements, delete and update and things like that. But actually, it's got a very, very small difference, and those are things called record IDs. And then those record IDs enable you to jump directly to a record without an index in a table. I think working out how that query language would work, even though it seems such a small difference and such a small change from the traditional SQL, was probably the hardest challenge. And then working out how that could work through the engine, through to the key value storage engine underneath, in order to get the performance and the scalability that we desired. So just working out how we could get these different models together in a performant way was, I'd say, the biggest challenge.
Yeah, and designing a language, it's yet another skill. We talk about storage and distributed computing, but designing a language, a parser, a syntax, a semantic for a language, it's yet another field that opens to you.
Yeah, absolutely. And you know what? Just since it was me back then in terms of building the database, now we've got a team of 25 engineers, and that language has changed even more so, right? We've got much more functionality around programming language logic in the SurrealQL language itself. We've had a new parser written. We've simplified aspects of the language where it was, you couldn't quite ascertain whether it was doing X or Y. So it's definitely become more formal, which is great. But it changes. It improves over time.
You talk about parser. The only one I know is Yak and Lex. And when I say I know, it's by name. I use them. That's the type of technology you're using. There is a binding for these.
So I don't think we've got bindings for those. Everything we've built in terms of this new parser is handwritten. But we are, so it creates an AST at the end of the day, and we're looking at ways of improving how you can interoperate or integrate with that AST in terms of language servers and things like that.
Quick word on your business model as well, because we said it's open source and you've started alone, but no, you just mentioned there is 25 engineers working on that, so you create a company to sell SurrealDB. So if a customer, if I'm willing to buy support, that's the type of contract I can buy from SurrealDB, the company?
Yeah, absolutely. So obviously we have our managed cloud database running in AWS right now, and you can spin up instances easily, spin up distributed clusters as well. And also for the large organizations, we have an enterprise support model where we can help you build or migrate or design and work out the best ways of, if with a database which is as flexible as SurrealDB, there are a million different ways of storing your data, as you can probably guess. We also have a lot of customers, large enterprise customers and governments running on-prem. This is something I think there's a slight trend to having more control as well in some industries. So we also support. We have an enterprise edition of the SurrealDB binary, which has certain logic or functionality which is only applicable to enterprises really or governments. And then we also have a support model for again building your application and running your application off a cloud or maybe in a cloud but not managed by us.
Yeah, so that's a lot of different options. It can be on-prem, I guess it's Kubernetes as well, which is used for on-prem deployment. It might be in my own cloud environment or in your cloud environment as a SaaS solution or software as a service solution. If I want to deploy on AWS on my account, is it something I have to do manually, or is there an AWS Marketplace solution I can just click and deploy?
We're actually here today talking about the AWS Marketplace. So we haven't launched that just yet, but later this year we'll be on AWS Marketplace, and we're also working on being an AWS partner as well. So yeah, there are going to be many easier ways of deploying SurrealDB in AWS or in the cloud generally. I'd say it's not just about deploying in the cloud. So SurrealDB, because it's embedded, because it can be running in Rust or as a single node, it's also interesting to customers that they can run on the edge. They can spin this up and run it in their applications that are running on an edge server or even on device, let's say in a browser or an iPhone or on a device that's moving around, let's say, and then syncing that data back up to a SurrealDB deployment in the cloud. So there are lots of different ways of deploying, which become very interesting depending on the type of user you are.
When you say at the edge, I'm thinking about small devices as well, like IoT device. It's technically possible to run on really small devices.
Absolutely, yeah, absolutely. We've had users running us on Raspberry Pis, on edge devices with GPUs. There are lots of different ways of deploying, which all have their different benefits and negatives, but yeah.
So the next question is probably very hard then. It's what are the typical use case from your customer?
The biggest use case is real-time decision making. So when you want to really get better insights into your data, but you want to make fast decisions on those, let's say that's for displaying an ad on a site based on previous page viewing history, or maybe it's on previous behavior. You need to have very fast access to that behavior, very fast access to that previous page view history, and you need to make a decision in milliseconds and then display the correct ads. You need to be able to combine lots of different data together, whether that's through graph or from metadata through document, or maybe it's just tabular data. But then you also need to be able to make a decision very quickly on that. Product recommendation is another one. So basically anything where you need to store a large amount of data, usually different types of data, and query that in a certain way that you can get almost a guaranteed response time. Maybe that is listening to the input of an audio file or watching a video file and seeing what's happening in real time and then making decisions based on that. So all of the use cases that we're seeing from customers across all of the different industries is usually a large-scale knowledge graph where you can distribute it for fault tolerance and high availability, but where you need to be able to say, I need to query in a graph-like way, in a key-value way, and a document way in order to make a real-time decision based on data that is always changing. And that's another important point. SurrealDB, because you can choose and you can scale out the storage from the compute layer separately, you can say, right, I actually need a lot of writes whilst reading, or I need more reads than writes. So you can scale out differently depending on your needs. And therefore, you can continually update your knowledge graph while making real-time decisions on that data at the same time.
While preparing for the recording of this episode, I read a couple of benchmarks about SurrealDB, but listening to you, I realized there is no way to create a relevant benchmark. There are so many different use cases, from very small system to multi-node cluster in the cloud, a lot of data, small data, a lot of memory, small memory. How do you compare when you fit in one category, when you compare yourself to similar database in the same category? How does it fit in terms of latency and performance?
Yeah, so effectively we're sitting kind of right where Postgres and MongoDB sit in terms of the queries that you run. I think the interesting thing is it also depends on how you write your queries. So, for instance, if there's in SurrealDB, it's incredibly quick to go and get a single record if you know its ID. You don't need to say where ID equals 1 and then it either uses an index or a full table scan. You can go directly to person Toby, and that will bring out that record without having to do a table scan or an index scan. But users often coming from other databases might say, okay, I want to do a select all from person where ID equals Toby, and then that will do a full table scan and can appear very slow in SurrealDB. So it's also about how SurrealDB is a new type of database, and there are slightly different ways of doing it, even though it looks very similar in some ways. So first of all, it's very hard to do benchmarking generally because not only are we comparing ourselves with document databases, with graph databases, with single node, with embedded, with distributed, within memory. And, our benchmarks did try to touch on many of those different types. We compare ourselves with Redis and Dragonfly. We compare ourselves with MongoDB. We compare ourselves with Postgres and MySQL and SQLite. And these are all very different. And also, as you say, users are using us in different ways, storing different data with different requirements, maybe high read, high write. So it is incredibly hard to do the benchmarks. It's one of the reasons why it took us a while to actually get to that point where we could release benchmarks. But it's something we're going to be continuously updating. And as I say, in terms of general queries that you might expect from something like MongoDB or Postgres, we're sitting right exactly where they are sitting for those use cases. So
you convinced me. I'm a developer. I want to get started. Where do I get started?
So you can jump to SurrealDB.com and you can download the database there as a binary. We're also running on Docker, so you can pull it from Docker. I think we're SurrealDB/SurrealDB. We've got Homebrew as well. So if you want to run it on a Mac computer, you can just install it with Brew. Lots of different ways of running it. And in addition, you can go to surrealist.app, and there are easy ways of showing you how to get going and install it. Obviously, as well in our cloud, single click and you can have a free instance up and running, or a couple more clicks and you can have a distributed cluster up and running as well.
And you said there are SDK for different programming language. Do you have the list out of your mind?
Yeah, so we've got Python, Golang, JavaScript, Rust.
Rust, obviously. Java?
We've got Java. We're just about to be making that stable 1.0 release very soon. So Java supports the embedded database as well. I'm trying to think what I've forgotten now. We've got C#.net and we've got PHP.
So the major programming language.
All the major ones. We're looking to support additional ones soon as well. Oh, we've got C as well. C coming very soon.
Oh, yeah. And then from C, maybe we can bind other language like Swift.
So actually, it's through the C library that we're supporting embedded within Python and embedded within Go, because they interoperate better with C than they do with Rust.
SurrealDB.com, that's your starting point in this journey. Thank you, Toby, for your explanation.
Thank you.
And answering my naive question from someone that doesn't know much about the theory of database. I'm more on the user side as a developer. Toby Morgan Hitchcock, you're the CEO and co-founder of SurrealDB.com. We were recording this episode live from the AWS Summit in London. That's why there is a bit of background noise, and you will have more episodes like this one to consume in the next couple of weeks in all your good podcast applications. But now, go build.